I actually had an issue last night where I was trying to stream and it didn't work because I had changed the resolution settings and YouTube didn't like my resolution settings. That was very unpleasant.
Uh,
All right.
yeah, I was once supposed to give a talk to a audience by Zoom, and I wasn't sure that the apartment I was staying in had good internet connection. So I went to an institute in Chicago that does a lot of Zoom talks from it. It turned out that they had some sort of firewall or something protection that wouldn't allow my laptop to work. So I was panicking. Like 5 minutes before I was supposed to go on and talk to hundreds of people, I had no way of connecting with them. We got it straightened out, thank goodness. But
That's good. Yeah.
this technology is
Yep.
very,
Yep.
very anxiety inducing.
All right, so we are live, Dr.
Okay.
Barr. Thanks again for coming on. Let's just jump right in, I guess.
Okay. Well, let me make a plug, because since you have such a big audience, as I understand it, I'd like to spread the word about something. So I'm the president of something called the Society of Catholic Scientists, and we're an outfit that I and a group of friends started it 4 years ago, summer of 2016, and we've grown now to 1,300 members. In 50 countries, though they're mostly in North America still. It's what I guess the biologists would call a founder's effect. But we have a website which had a lot of stuff that your listeners or viewers might find interesting. And they can Google Catholic scientists and they'll find it. But it's called the Society of Catholic Scientists, and it's catholicscientists.org. And so we have articles, some philosophical, historical, scientific, theological. We have common questions about science and faith with answers that they might find interesting, and so on. So anyway, I just wanted to plug that.
Do you guys have like a forum where you can ask questions and converse with each other?
There's a member forum where you have to be a member to discuss things. We don't have personnel to moderate things and stuff. We don't have any paid permanent staff, so we just don't have the wherewithal to have that.
Gotcha.
So I was saying to you before we came on, I apologize that I talked so much last time and didn't give you a chance to speak, but I realized later that there were things you were saying that I had probably misunderstood. So I kind of interested in some of your philosophical views about science. So one thing that I realized, we are probably talking across purposes and maybe misunderstanding each other. It had to do with laws, the laws of nature, the laws of physics. So I'm curious how you think about the laws of physics and what they are. And you're a philosopher, and philosophers debate all sorts of questions that physicists never think about, such as, are the laws of physics prescriptive? Are they descriptive? What is their status? What do you think of them? And in particular, thinking of the mathematical laws of physics. That's what I, as a physicist, care about.
Yeah, absolutely. So I think that they are descriptive. I tend to go on the naturalistic side, the nominalistic side, where there is no actual abstract universals that actually exist anywhere. It's purely just something that follows from the human mind. So, for example, I start with the cogito, I think, therefore I am, and then from that, we see that there are differences between our imagination and reality. I can imagine a unicorn, but I do not see a unicorn in front of me, or a difference between our imagination and our experience. And then we can describe those differences by saying, well, the unicorn has these properties and the TV has these properties. And we find relationships in those descriptions, like the laws of logic and math flow from those. So I can say this object is this object and not that object. And A equals A, and A is not A. So that's where you get the laws of logic from. And math is just, well, there's one of those, but they don't exist anymore.
You just said something in passing that is very interesting, because I've always been fascinated by the philosophy of mathematics. I'm not a philosopher and I'm not a mathematician, but it's one of the few elective courses I took in college was the philosophy of math. So you said, we have experience, we don't see unicorns, we do see these things. And then from our experience, we say, well, we see this type of thing and that type of thing. And we find that there are, from those, we derive the laws of logic and the laws of mathematics, and somehow. So the laws of mathematics, I'm just curious, do you think that they are ultimately generalizations based on empirical, on experience. I mean, that was sort of like Aristotle's view.
Well,
You know,
that's
that you see round thing, like you see round objects, and from that your mind abstracts the idea of roundness from the experience of round objects, and the mathematical entities are abstractions from from empirical
well,
data.
that's how epistemically we came to math, yes. But I think there is an ontology to it, which it describes something, but math doesn't exist in and of itself. It describes reality. So roundness is a property of objects. It doesn't,
So
roundness itself does not exist.
what about mathematical concepts that don't find any that don't describe anything in the physical world, in the natural world? What about those? What about the 17th root of 19?
It's a description. So we take things in reality and we derive abstract mathematics from those. Just like if we take a horse and put a horn on it, we get a unicorn. We can take vectors and make imaginary numbers out of them, even though they don't directly correspond to something in reality. The underlying math does, where we get 1 + 1 = 2, and just those kinds of things.
Okay, so they're descriptive. I think I sort of agree with that. I do think that they're the laws of physics. So what about equations? What about something very abstract, like Maxwell's equations of electromagnetism, or the postulates of quantum mechanics? You know, which are a set of mathematical rules and procedures and so on. What do you think? What is their ontological status, or what are they?
They're purely descriptive. So there's like sentences like that is a tree. So essentially they're the same as fluid dynamics. They're the mathematical equations that describe the functions of how water interacts. And Maxwell's equations are the equations of how electromagnetism interacts and the fields interact.
Okay.
So they don't actually exist anywhere. They're just essentially like English sentences that describe the thing that does exist, which is there.
Right, but surely they're describing relationships among things.
Sure.
And those relationships exist in the real world in some way, as relationships, not as objects, but as relationships among things.
I don't know what you mean by relationships exist.
There's something in reality. They are describing features of reality. You're not denying that.
Sure, absolutely. Like fluid dynamics it also does too.
Okay. Now, why are there laws? Why do there have to be mathematical laws?
Well, math.
I mean, just that's not why they have to. Why are there mathematical laws? Is there some reason for that? Do you think? I mean, other than we know there are. You and I agree that there are these mathematical laws that describe the physical world.
Yeah, I'd say just describe reality. So yeah, I'd say that's
reality. Okay, well, we can prescind from the question of whether there's more to reality than the physical world, but we both
I would
they describe the physical world.
I would say that math would describe any possible world. So if there's a non-physical world, math would describe that. So I'd say that math is a fundamental language that describes the way reality is, regardless of whatever reality
any possible reality.
Yeah, essentially, for sure. So because reality is reality, and that's where we get one. There's one reality, which is all existing things.
That's another topic we can get into it. So why? But I'm not asking you. I'm asking you, why are there math? You say any reality that existed. I don't know what your view on modal state. Any reality that existed would have some mathematical laws. You're saying it would sort of have to. Is that your view?
Yeah. So I'd say that any reality that existed would itself be reality, and so you'd only have one of them there, and so that language we've constructed of math will describe that reality, and it will describe any reality. The laws themselves could be different.
Back and forth. The language we constructed, but.
Well, it's kind of like
I keep worrying that you're sort of subjectivizing it in some way, or making it some conventionalist view. I mean, you don't deny that the reality in our universe that somebody who did physics correctly on some distant galaxy
would come to the same conclusions,
the same equations that we end up with if we do correct. So
definitely,
yeah, I'm not denying that we invent the math. But but you wouldn't deny there's a correct way of doing it and an incorrect way.
Right.
Physicists try to find the correct way. right?
Yes. So like if
Okay.
I said there is a forest with 3 trees, that would be correct. If I said there is a forest with
Okay.
five
But
trees,
you
that would
make me
be
nervous every time you say this language we invent to do, because I mean, because then you could say, well, we invent French and somebody, French evolved, but, and then there's German and the rules of French are just conventional and the rules of German are conventional. But the laws of physics are not conventions in that sense. They correspond. The mathematical rules in Maxwell that underlie the equations of quantum mechanics or quantum field theory or whatever, Maxwell's equations, general relativity, assuming that it's correct. Well, exactly. They're correct. They are correct descriptions that anybody must arrive at who is trying to describe nature.
right. But the same thing would apply to English. Like English has correct descriptions of reality and incorrect descriptions of reality. Like saying I am a human being is a correct description of reality, and saying I am a Klingon would be an incorrect description of
Okay, but we
reality.
can get hung up on the language. I mean, math is a language. There's no question about
Well, I'm making a further claim. Math is a language no different from English or
it.
C++.
Well, not well. Within English, there are correct statements and incorrect statements. But in addition to English, there's French. I mean, so the rules of English, the grammatical rules, are entirely arbitrary. So, but in a way that Maxwell's equations is a set of rules, but those are not entirely arbitrary. I think that's where we're maybe not connecting. I agree with you that within one thing is the statements you make within a language. So, I mean, Maxwell's equations are made within a certain mathematical language. Okay, maybe I don't want to get hung up on this, but okay.
Well, no, I totally understand.
Worried that you're.
I totally understand the point you're making here. So the point I'm making here is math is a language about reality, whereas English is a language about our concepts. And because of what it's about, that determines the grammatical rules that are constraining the language. So a formal language.
Maybe I'm getting myself sidetracked. So I think we basically agree that the way you say things throws me off. It keeps throwing. Why? So as I understand what you're saying, any reality that you had, assuming reality could be otherwise than it is, hypothetically, any reality you had would have to have some, be describable by some sort of mathematics. There'd have to be mathematical laws that were its correct description would be in terms of mathematical laws.
Or English. I mean, any reality that existed would also be describable with English too, correctly and incorrectly.
Yeah, but when I say there's a bird sitting in a tree, that's not as fundamental a statement as Maxwell's equations. I mean, do you think there are fundamental laws of physics? We don't yet know. I will admit, we don't yet know what they are. It could be superstring theory, and if I had to place a bet, I would say it's probably superstring theory. But we don't know for sure with any confidence what the ultimate laws are. But most people in my field, I think, not everyone, but most people think there are some set of ultimate laws of physics, to which the Standard Model and Einstein's theory of gravity are very good approximations and so on, down to some distance scale. But they think there is some ultimate set of laws. Do you think there are some ultimate set of laws?
Yes, in our universe, there's definitely some ultimate set of laws that govern everything, but those ultimate set of laws would not be necessary in that they don't necessarily need to apply to all possible worlds. Like you can have.
Okay, good. I agree with everything but that's different from. So, but that gets you a much more fundamental. You would agree that those fundamental laws in relationships are that those fundamental laws are more fundamental in the sense that, in principle, you can sort of derive from that more fundamental viewpoint the less fundamental viewpoints, right?
Sure.
I can say, I burned this piece of wood and smoke came out. That's fine, but that's rather crude description of what's going on, and the more fundamental levels of physics will get you to the more comprehensive and complete and accurate account of what's going on, right? I mean, that's why I say when you keep saying it's like English, but there's a sense in that the laws of physics statements about reality and so statements in English, but there's a sense, I would think, as I think you're a physicalist or a materialist, there's a sense in which the laws of physics have a sort of privileged status as the most fundamental ones from which other things are derivable, right? Wouldn't you agree?
Yes, that's because math describes reality. That's like
Okay, good.
what math
Okay,
is meant to do.
good. We are on a common ground here. But why do the laws? Let me ask you this: do you think if we make a measurement of a physical system today in one place, and we make a measurement of the same kind of physical system, so suppose it's an oxygen atom, I don't know, if you pick your favorite physical system, and we make very precise measurements, we find it has energy levels, and there's certain decay amplitudes for going from one excited state to another, whatever. Or it could be the lifetime of a muon, or it could be whatever your favorite thing. And we measure those very accurately, and we find certain equations satisfied. And then you look at an oxygen atom 10 days later in the lab in another part of the world, you find exactly the same patterns, the same mathematical relationships, the same laws. And in fact, you look out to the farthest reaches of the universe, looking at things that are billions of light years away, and in fact, billions of years in the past, you find exactly the same patterns and relationships. Why? What's responsible for the fact that the pattern you find here and now is the same as the pattern you will or would find at very different times and places? Is that something that had to be? That a reality had to have that feature? Any reality had to have that feature?
Sort of. So any reality is going to have some kind of a pattern to it, but the pattern itself could be different patterns. So, for example, reality could be completely random in a sense where things just change and oxygen atoms aren't the same in locations or whatever, but that's still going to be some kind of a pattern.
There's some kind of pattern. That I think I would agree with that. That if something had no form at all, maybe it wouldn't exist. I mean, it has to have some form. But still, I'm asking, but that's fine, that there has to be some kind of pattern. But the fact that there's some kind of pattern doesn't tell me, it's still pretty astonishing that, some of these things, here's a little electron doing its thing over here. And we measure, I forget how many decimal places, but one of the most accurately measured things in physics is the anomalous magnetic moment of the electron. And it's measured, I forget whether it's 8 or 10 decimal places. And then this Japanese guy named Kinoshita back in the 60s and 70s and stuff, before supercomputers, he spent most of his life calculating this quantity from first principles. And he calculated this 7 or 8 decimal places, and by God, it agreed. It's one of the most astonishing things. But this electron, stupid little electron doing that, he didn't spend 7 or 8 years or half his life calculating. The electron just did it. It did what it reacted to magnetic fields to all these decimal places, just as Kenosha had calculated it ought to. But that's amazing enough. But it's amazing that if you were to measure this property of the electron any place, anytime, some other electron, an electron on the moon, it's going to do exactly the same thing as this electron here.
Yeah, I totally understand your point, but I don't see.
I mean, you could say, well, there has to be a pattern.
Well, yeah, that's the thing, is that
wrong pattern. Why is that? Why does that happen? Why these electrons never talk to each other? These electrons had no communication with each other.
I don't see.
How did this one know to do exactly the same thing as that one?
Yeah, I don't see anything special about the pattern we have as opposed to a different pattern. I don't know why we would think this pattern is special as opposed to seeing a different pattern.
I'm not saying anything about whether the pattern is nice or special or characterizing it. I'm just saying what's amazing is not some. What amazes me is that the patterns of behavior that this electron in my laboratory, I'm a theorist, but that this electron in Delaware has exactly the same pattern of behavior as an electron a million miles away, a million years different in time. Those electrons never talk to each other. They don't communicate. This one can't say, I did this, now you do the same thing. They don't know about each other's existence, yet they do exactly the same thing. I can understand that it's maybe a philosophical necessity. I think I agree with this. This is a conclusion I've also come to, that any kind of reality has to have there has to be some kind of form. There can't be complete formlessness. That's a very weak statement. There has to be some kind of form. That's extremely weak. The form, the pattern that I'm talking about, or the order, to use a word that we talked about a lot last time, the order involved in this electron here and the one on the other end of the universe doing exactly the same things in exactly the same way. That's very strong. So I'm asking, where did that come from? Why is that the case? Don't tell me there has to be some kind of order. I agree. Why that degree of order? You don't find that surprising or in any way remarkable? Or
Not really, no. I think it's just a feature of reality. So it's...
Let me read something by an atheist. I won't use his name because I don't want to drag someone in unwillingly into our conversation. He's one of the top astrophysicists in the world. He's at Harvard. He was being interviewed by somebody about something about, what the interviewer thought that some of the things this guy was saying was sort of weird. They had to do with science. And so he thought, if this guy's weird, maybe he's religious, that's the way some people think. So he asked this very famous astrophysicist who is an atheist. He said, "Are you religious?" And the fellow said, "I was secular." Now, pay close attention. He said, "I was secular to start with. I am not religious." I'm not sure why he said to start with, but he said, "I am not religious. I am struck by the order we find in the universe." Now, it's interesting because the guy hadn't asked him anything about order. He'd asked him whether he was religious. The subject of the order in the universe had not come up in the conversation. "I am struck by the order we find in the universe, by the regularity, by the existence of laws of nature. That is something I'm always in awe of. How the laws of nature we find here on Earth seem to apply all the way out to the edge of the universe. That is quite remarkable. The universe could have been chaotic and very disorganized." He didn't say totally without form, but it could have been very disorganized. But it obeys a set of laws much better than people obey a set of laws here. Now, just want your audience to know, this is an atheist talking, a rather seemingly convinced atheist. He finds it remarkable, the kind of order I just talked about. He doesn't say it proves God, and I'm not going to try to argue that it proves existence, but he finds it remarkable. I don't understand how you cannot find it remarkable, because frankly, I think just about anybody in my field who's at all thoughtful finds it quite remarkable. And I think I just don't understand. Anyway, but you don't. Let me quote.
Could you tilt your camera down a little bit? Your head's starting to float down underneath the screen.
That's fine. My face isn't very photogenic anyway.
But yeah, I totally understand the argument, but I think it's no more remarkable.
It's not an argument. Well, it's not an argument. It's not an argument. There's no premise and no conclusion. It's simply an observation that this is.
So I think it's a gambler's fallacy.
And remarkable fact.
Yeah, so I think it's just a gambler's fallacy. Like if you roll any dice, there's a bunch of different combinations that it could come up, and you see you roll 6 dice and they all come up as 6s, like, oh, this is remarkable. But when you really look at it, it's no more remarkable than 1, 4, 3, 5, 7, 2. All the combinations are exactly the same probability. So the fact that the universe has regularities and that an electron here works the same way as an electron there is no more special than if it didn't.
I'm not going to talk about this more because I think we've laid our cards on the table. I mean, I agree with you that if you roll a pair of dice, well, let's say flip a coin. Flip it 100 times, then there's 2 to the 100 possibilities, and they're all equally probable and sort of a priori. There's nothing special about all of the flip coin tosses coming up heads of the 100 coin tosses any more than any other distribution. And yet, if that's what it is, then there's no reason, if that's what's going on, and I flip the coin 100 times, and I find, oh, it came up 100 times heads. Well, of course, the suspicion would enter one's mind that maybe the coin was loaded, but you could just, it's quite possible that, that's no more unlikely than any other pattern that could have come up. But I'd have no grounds then for thinking that, but if I were then to predict, to talk about the Monte Carlo fallacy, since you mentioned the fallacy, It would be a total fallacy to conclude from the fact that I came up with 100 heads in a row to think that the heads were more likely to come up next time. That's I think that's called the Monte Carlo fallacy. At least when I was a kid, that's what I was
it's
told.
because of in Monte Carlo
Now,
there's
so
a
there's
case.
no reason whatsoever to expect it to come up heads again next time, or to be more likely to be heads. And certainly no reason to think that the next 100 coin tosses will all come up heads. And so there's no reason to think that the laws of physics are going to be obeyed tomorrow. That doesn't make sense to me.
Well, the problem of induction, that's not exactly the way I'm going here. So I'm saying
No,
that
I don't care where you're going, but you just said that it should not be remarkable that we find the pattern I'm talking about, that the electron here, the electron there, the electrons over there, they all do the same thing. You say that's nothing special about that. They all had to come up some way. They all happen to come out the same. The way if I flip 100.
Yeah, that's not the way I'm going with the argument.
There's nothing remarkable about it.
Let me interrupt here. So the thing that's not remarkable is that if we think of the universe as a patterned universe where every electron has the same property, and we think of a different universe.
Wait. Well, okay, it is, but why? Okay,
I'm getting there. We're getting there. So if we think of a universe where all electrons have the same properties, and we think of a different universe where they don't all have the same properties, why is this universe where they all have the same properties any more or less special than the other universe?
Wait. You see, now you're bringing into something that you're predicating of all these different electrons that they quote that there's this thing called a property that they have. And well, from the mere fact that I call them all electrons, I'm assuming that they have something in common. And I posit, or somebody posits this. I don't like this way of thinking about it, actually. They posit this property that they all have. Well, if they all have the same property, they're all made of electron stuff or whatever, then there's no big surprise. They all do the same thing. That's just a redescription.
Yeah, that wasn't
of the original observation.
Let me interrupt here. Let me interrupt.
Did the same thing. So I mean, the Dragular property isn't that explains it. I don't need. Let's not talk about other universes. I'm talking about this universe.
Stephen. So the property there. You're right. That's just a redescription of the same thing, because that wasn't the point of my analogy here. So if you're saying that if we look at this universe and we look at all the electrons work in the same way everywhere in the universe, and that's really amazing, right? That's
yes.
And I'm saying
it is something that seems to call for an explanation.
Absolutely. So I'm saying, well, if I look at a different universe and I say, well, in that universe, they don't all act in the same way. In that universe, some electrons here work in a different way than some electrons here. Why is that any less amazing? Because they both seem to be amazing. They both seem to equally require an explanation.
No, I don't think that seems much less amazing. So if I flip the coin 100 times, and I have no a priori reason to think that I know that each one can come up heads or tails, and a priori I have no reason to expect one more than the other. It is amazing if they keep coming up over and over again after a long bunch of tosses, the same. And certainly it in a certain sense it's not remarkable, because it's no more or less likely than any other particular choice. If I walk to the other side of the room, the exact place where I put my feet, it's not a miracle. Wow, he put his feet exactly in this spot. No, had to put it somewhere. But I understand that. But on the other hand, if there's no reason for them all to come up the same, and they do all come up the same 100 times, then I might have to revise my idea that I tend to think, well, either it's an astonishing coincidence, something that's very unlikely to happen happened, and sometimes and many times unlikely things happen, or I have to say there's a reason for it. There's a cause. Now, and if I say there's no real reason for it, it's just the luck of the draw. Then if I say that, then I have no basis for expecting the thing to keep happening that way. In other words, if the regularities I see in the natural world, which are quite striking, if I think they're just the luck of the draw, then there's no reason to believe that they will hold tomorrow.
But yeah, I think I see what you're saying. So yeah, I think they're all determined by some part of nature.
There's something causing them, somebody's or something or some ultimate reality or whatever you want to call it, is sort of causing the electrons. The electrons aren't causing each other to do this because they have no connection to each other. They can be causally disconnected from each other.
Right.
Something else, some third thing, or whatever it is. I don't want to prejudice it. I'll use the word thing because it's pretty vague. Some third thing is causing those two things to do the same thing. Okay, right?
Yeah, absolutely. I totally agree.
All right, good. We've gotten somewhere. Good. I think we've made some progress here. Can I just read one more quote from an atheist?
Sure.
Well, not an atheist. It's Ed Whitten, and you probably know him.
M theory guy, yes.
Well, he's done a lot more than that, but he you know Ed Whitten. He is, most particle physicists think he's the most brilliant particle physicist in the world. Sad to say, he's not religious. He describes himself as a skeptical agnostic, which could be a polite way of saying atheist. And he said, and I think this is interesting, he said, the laws of nature, and he was a little redundant because he wasn't writing this, it was off the cuff. The laws of nature, as they've been uncovered in the last few centuries, and especially as they've been uncovered in the last century, are very surprising. They're very subtle. They've got a great beauty, which is a little hard to describe maybe if one hasn't experienced it. The laws as we know them are beautiful mathematically. They involve very interesting and subtle concepts. It is a rich story. It all hangs together beautifully. Even if we find the final theory of physics, and he's optimistic we will, maybe have, I think there will be some why questions that will still be with us. I think we'll be dazzled, as in fact we already are, that this theory exists. He's dazzled by the regularities that he sees. But in a way, why it exists is a bit mysterious, and why we live in a natural world that's governed by it will be mysterious. So he's actually, I condensed what he said, but he sort of rhapsodized about how striking and remarkable the laws were in their subtlety and beauty and sophistication and so on. So I'm just saying, this is aesthetics or something. Your view leaves me cold. That is, it's sort of like, well, you know, there had to be anything that exists has to have some kind of order to it. Well, and otherwise, if it was completely formless, it wouldn't have any definite existence or anything. It wouldn't be a definite anything. It wouldn't exist, perhaps. And so there has to be some kind of order. And yeah, we find order, but there sort of has to be some kind of order. Why not this order? If that's your philosophy, I think there's something missing from your attitude. I'm not talking about any arguments you make or conclusions you draw. I think you're closing your eyes to something. That's my impression. But let's get away from laws, because I think we've gone.
Well, actually, I want to bring up on that exact point. So I agree with you on pretty much everything there. The difference is that the same thing applies to any possible worldview. So Ed Whitten's response would apply to everything. So if there's a God, you still have why questions. If there's no God, you still have why questions.
I think you still have the same question, but I think you at least have the beginnings of an answer.
Well, no, this is my position, is that you can't have an answer. It's all going to be asserted. I can assert an answer to the question, and you can assert an answer to the question.
I'm not saying I can prove my answer, but here's how I.
Oh, no. I'm just
I'm not saying I can prove it, but my
totally
answer would be something along these
lines. Let me finish.
Oh, yeah, okay.
Okay, so this isn't about, we can just assume God is real, or we can assume whatever hypothesis is real. We don't need to prove it. This is just for the sake of argument. So if we assume God is real, he is the ultimate theory of everything. No. It's
not a theory.
That's just
superstring theory.
Figure of speech.
Theory of everything.
Figure of speech. So the point here is that whatever we think the ultimate nature of reality is, you're still going to be left with the exact same questions of why is it the way it is. This is a problem in philosophy known as Agrippa's trilemma. Is it a brute fact and it just is necessary truth, a brute fact, necessary truth, or is it an infinite regress of some kind, or did it cause itself? There is no solution to that problem in any worldview. You can't have an answer.
I'll tell you, I understand what you're saying, but I don't want to spend the rest of the half hour on that. But I just what I would say is, As you said, I agree with a lot of what you said. Most, or maybe everything you said about the laws of physics. That is, they're not necessary. They could have been. There could be universes with different laws, and probably any universe has to have some kind of form, however trivial. It has to have some kind of form. I agree with all that. I would make the analogy. The analogy I would make is that the universe is like a game. I think I may have said this last time. Like chess. Okay. Chess is like a mini universe. Now, if I'm a kid and I'm watching two people play chess and I'm watching the board, I'm not even focusing on the people. I'm watching the board and I say, wow, I noticed the bishops, they do these things. They move along these diagonals and so on and so forth. And knights do certain things all this time. And this knight always does the same kinds of things as that knight. And I see these patterns and regularities, and I say, why is that? Well, in that case, first of all, the rules of chess are not necessary. They're not like the rules of arithmetic, They could have been different. In fact, chess players often play variants of chess. Let's add some extra rules. It would change them. But the reason they're doing that is somebody made a decision. That is, the rules were chosen. The reason the pieces are all doing the same thing is that the players decided between themselves, let's play chess and let's play it according to these standard rules, or let's play it according to these other rules. So I can see how a mind could make a decision that certain things subject to that mind's control happen according to some set of rules that are chosen by that mind. Now, you can argue all sorts of things about whether that makes any sense, whether you believe in God makes sense, but that at least is something resembling an explanation of why the regularities are happening in this little universe we call the chessboard.
Well, actually, it's not. That's kind of the problem because, well, did that mind choose its own nature? How did that mind's nature come about?
That gets us back to subjects about necessary beings.
Well, right. This is the point of the conversation.
Well, let's come back a third time and pursue it, because there's a couple other things I'm really curious about.
Well, I just to summarize my point here is that if you want to say that God solves the fundamental nature of physics, he's the explanation. I can just say there's a quantum particle that solves it, and God's nature, which whatever it is necessary, causes the world to be as it is. Well, the quantum particle's nature can be necessary, and it causes the world to be the way it is. And either one,
particle's nature is actually follows from a set of rules, so it doesn't.
No, so not this one. This is a new particle that we haven't discovered yet, so it's a necessary particle.
Okay, and its nature is necessary.
Yes.
And that nature is described by a set of mathematical rules, like laws.
Just that it is itself. So one, just like God is one, it is one.
No. But that's it. Okay, this actually gets to the other thing I was going to ask. You're saying there's a necessary reality. You said that last time. That really confused me, because the more you talked about it, the less I understood what you were saying. You said at one point, you said there's got to be a reality, right?
Yes.
And you seem to say there's some sort of necessary, I don't know if you want to call it an entity, but let's say a thing. I don't in the vaguest possible sense of thing. There's got to be some necessary thing.
Yes.
And tell me about that.
Well, I have no idea what it is. It's just whatever the fundamental nature of reality is, that's the necessary thing.
Okay, so okay, you told me something. It's the fundamental nature of reality.
Yes.
Are there any possibilities that occur to you as what that might be? I mean,
infinite. There could be many different things that it could be.
Well, I mean, ones that you regard as real contenders.
Oh yeah, I think it's probably some fundamental field, like just an energy field of some kind.
An energy field. Okay. Let me ask you a question. So there's got to be a reality. It wouldn't make sense to say there's got to be some reality. So in some sense, reality, it's like there's got to be some kind of reality of some sort. So reality itself, in a sense, is a necessary.
Yes.
And there's some sort of fundamental level of it, or deepest core of that, which is somehow maybe explains
all the other stuff. Else. Yeah.
Something that's sort of explanatorily prior to everything. Something aspect or core of that reality, which it could be a what did you say? A
field,
an energy field or something. Do you think there could? some people wouldn't like this idea, but I personally think there could be more than one universe. Is that something you think makes sense to talk about?
Sure.
And when I say more than one universe, a lot of people who are not physicists think that multiverse refers to more than one universe, which it doesn't necessarily. It doesn't usually. A multiverse is a kind of universe. It's a kind of universe which is sort of very variegated. It has different parts that are very different from each other in character.
That's why Carl Sagan used the word cosmos just to mean everything.
Right. So I'm saying there could be more than one universe that have nothing whatsoever to do with each other.
Multiple cosmoses, essentially.
Yeah, okay. Cosmoses, they have nothing whatever to do with each other. They are not in any way causally related to each other. They don't interact. They're just completely disjoint and distinct and unrelated. And there could be any number of them as far as I'm concerned. In fact, if I were a modal realist like, what's his name, Max Tegmark, I would think that all possible ones exist, but there'd be uncountably many of them. Now, suppose there were 3 of them, or I'd pick your favorite numbers. Let's say we're 3. Is there a common reality? You say reality has to exist. Okay, so there's this reality, fundamental whatever, that has to exist. Are there 3 of them, or in that case, or are there 1 of them?
Well, it depends on how you define it. So they would all have some essential spatial relation, or they all occupy some kind of a dimension of.
Oh, the 3 universes?
Not like as in, because they don't interact, that means they must operate in different space times, and so they have a relation in that they are somehow parallel but not intersecting.
No. That's not what I'm talking about.
I understand. I understand what you're saying. This is so.
No. Each one has its own space time.
Yes,
There's no space in which they're embedded.
That's what I said. That's what I said. They all have their own space time. None of their space times cross or interact in anything. So they're completely separate dimensions. Essentially, they never cross.
But there's no overarching space in which they have any distance from each other or anything.
Right. So, but that thing is, they have that similarity. They all have a space time which is separate from one another. They operate at a separate dimension of some kind. But they all exist.
Okay. So far, all I said is that they are cosmoses and they exist. So that's the only thing they have in common so far is they exist.
Well, they also have something else in common, which is they don't interact with the other ones. They're separate. And that separateness is also
a negative statement. Something that they. Okay.
So they are all made of something, and that's fine. And so we have statements that can describe all 3 universes, but those statements don't actually exist outside of the universes.
I'm not asking that. I'm just saying, is there 1 reality or 3 realities? Because you said that there has to be a reality.
Yeah, I'd say that as 1 reality. I'd say reality is everything that exists.
There has to be a reality.
Yeah.
And it's somehow necessary that there be such a reality. And in this case, you'll say there's 1 reality.
Yes.
Okay, that's fine. I like that. I agree. Could there be 0 universe, cosmoses?
Yes, but that would still be reality.
And that would be a reality.
Yes.
What could you say anything about that reality? Is there any true statements about it?
That it doesn't have universes?
Does that really say much? If I say you're not a flying spaghetti monster, that doesn't really tell me a lot about you. It's almost a vacuous state. That's
well, I don't think there can be
no attribute. There's nothing.
There can't be a philosophical nothing. A philosophical nothing is impossible.
There's nothing I can predicate about it, except that there's nothing I can predicate about it. In other words, we say, well, it's not this. That's saying I can't. It's not a spaghetti monster. That's simply saying I cannot predicate of it that it is a spaghetti monster. But there's no positive statements I can make about it.
Well, I'd go further. I'd say
it's another way of saying that I can say that's a statement about it. There are no positive.
Well, no. I'm going to go further than that. I'm saying there is something there. Something has to exist. There cannot be.
In other words, if there were no 0,
I have no idea.
There's still something there.
No. I'm saying a philosophical nothing is impossible. There could never be a nothing. So
Why?
There could be no.
Well, is 0 universes a philosophical nothing?
No, there could be things other than a universe. So universe.
I use universe as a set of entities that actually exist. A universe I'm defining it. It's a set of entities that actually exist that have some sort of causal relationships among themselves. Now, Um, and we'd have to get very, you know,
So if by
obvious,
universe you mean just
so another galaxy, I might not directly interact with
right,
another galaxy,
right.
but I interact with this, and it interacts with that, and there's a chain where all of the distant galaxy is part of a collection of things that have causal relationships. That's all, and it could be this entity could be one thing that, and therefore its causal relationships are pretty trivial. It's just sitting there like the point guy in Flatland, who's in the zero-dimensional universe consisted of a single point. Okay, the universe could be just a point. It could be as trivial as you want, but it's something. But it has existence. That's all I'm saying. It has existence, and is somehow
Okay. Then I would
whatever
say it's
whatever it consists of, composed of, are causal relationships among each other, and that's a universe.
okay, sure. So I would say it's impossible for there not to be at least one universe.
There has to be a cosmos.
Yes.
I don't see why.
Because a philosophical nothing is literally impossible.
Why? Who says?
Because for there to be nothing, that means that we couldn't exist. Because philosophical nothing means it's impossible for us to exist.
There's a priori impossibility and a posteriori impossibility. If you say, did Abraham Lincoln, did what's his face? Who killed Abraham Lincoln? John Wilkes Booth. Did John Wilkes Booth have to kill Abraham Lincoln?
No.
Well,
unless you're necessitarian.
Given that we know that he did, then he had to. Given that I exist, I have to exist. That's really a tautological statement. Given that I exist, I have to exist. It's not possible that I don't exist.
Right. So
it's already a given that I do.
I understand. Yeah, I totally understand.
I had to exist a priori. You're saying a priori. Yes, obviously, whatever is true, it has to be consistent with the fact that I exist, which is a truth. But I'm saying a priori. You're saying a priori, there has to be some existing things, entity of some sort. There has to be some existing stuff.
Yes.
Why?
Because a philosophical nothing would imply that nothing could exist. That's entailed. There has to be some kind of.
No, it just means it happens that nothing exists.
No, that's not one of the possibilities. So because if nothing does exist, that means there is the possibility that something could exist, and that itself is a something. So there can't be a nothing there.
What do you mean? A possibility that something could exist is an actual existing thing?
Yeah, like
you're going to reify the possibility so that something. I don't know whether I actually do know something could exist because I exist, but I'm just saying there could have been a state of affairs a priori where nothing whatsoever existed.
No, that's not. No.
Now, if you
so let me present the argument again.
What does that conflict with?
So if there was a philosophical nothing, no space, no time, no fields, nothing, there would still be a place where stuff could have been.
Why? How do you know that?
Because if there wasn't that, then you couldn't have a nothing, because there'd have to be a reason that there's no nothing there, that there's no potential place that it could be. So
I don't understand this. You said there could be 17 universes. There could be 20. There could be Aleph null. There could be 3. There could be 1. Why not 0?
Because that's not possible. Because if there's 0, that's still a something. If there's 0 things, that collection is a something. So there has to be a something there.
Not necessarily. I mean, in set theory, you can make a set that's the null set, and that's a something. But I'm not.
Yes.
I can understand it if you want to say that mathematical entities have some. This gets into the philosophy of math. Do sets exist? You know, does Zermelo-Fraenkel set theory exist? You know, does the real numbers exist? Do the complex numbers exist? There's what you might call Platonic mathematical Platonism sort of existence. And I actually do think that there are mathematical entities which necessarily exist.
Well, so I'm not going the math route here.
Let's leave math.
Yeah, I'm not going the math route here. I'm saying if there is a reality, I understand. If there is a reality with philosophical, if there is a reality with a philosophical nothing, then there is no reality. That's a contradictory statement. You cannot have.
Well, why not? Why couldn't there be no reality?
Because again, if nothing exists, that is a description of reality.
This is almost like this reminds me of the ontological proof of the existence of God, which, I mean, it seems to me you're pulling a rabbit out of a hat. Now, I like St. Thomas Aquinas. I don't buy the ontological proof of the existence of God, though I think it actually is very, it tells us something. I mean, we can learn something about God from it, but it doesn't prove that there's a God. And it's like pulling a rabbit out of a hat, and I think you're pulling existence out of a hat. Yours is the ontological proof for the existence of the world, which it doesn't strike me as any more compelling than St. Anselm's argument for the existence of God. Anyway, all right, but I learned something. I now know what you mean, and that's good. And so we got 2 out of my 4 things. Here's another thing. The ultimate reality, as you understand it, one thing you did say about it last time is it's mindless. It has no mind. It's unconscious.
Well, that's usually an inductive argument. I can't conclude that, but yes.
You can't conclude it. But let's hypothetically suppose that it's the case.
Okay.
I mean, so I could imagine. So going back and say, okay, let me go along with you, even though I'm not sure I do. Let me arguendo. For the sake of argument, I'm going to agree with a bunch of stuff you said. There's got to be a reality. It's somehow, and it's a necessary whatever thing. It could be energy fields or whatever. And there's got to be one of them. It can't be 0, and in some sense, it can't be more than 1, because whatever it is that thing. It's reality. And let's suppose hypothetically it's just mind. So I can see that maybe there has to be something, and maybe there has to be whatever exists has to have some form. There has to be some kind of order. I agree with that. I actually do agree with that. It has to be some kind of form. It can't be. But couldn't reality have been such that there were no minds at all?
Sure.
Okay, good. So there could have been the total reality, the ultimate reality, the underlying reality with a capital R that has to exist, and the cosmoses that may somehow exist because of that ultimate capital R reality. And there could be 17 cosmoses. All of that stuff could be completely devoid of mind.
Sure.
Okay. So why is there mind? What's the cause of it? Because the ultimate reality doesn't cause it, because you could have an ultimate reality. You need to have an ultimate reality of some sort. It doesn't have to entail the existence of mind. So I'm left with the question of why, in God's name, are there minds?
But the fact that it doesn't have to be doesn't mean that it didn't happen. So.
No, but it means it needs to be explained, because there's no necessary thing. You've sort of explained to me in a way the order of nature. I mean, I think somewhat lamely, if I may say it that way, and to me unsatisfactory. You sort of said, well, there's all this astonishing, to Ed Witten and this other fellow I won't name, this astonishing mathematical order of incredible sophistication. Well, because it has to be order of some kind, and why not that? Okay, good. But there didn't have to be mind of any kind. And so that, it seems to me, then is something that does call for explanation.
Yeah, so some of the properties in the fundamental nature of reality produce a world that can create minds. It's a brute fact, a necessary truth.
Okay. And this completely unconscious, mindless ultimate reality so it has to produce minds. In other words,
it has to be.
There could be a reality, that there could be a set of cosmoses. There could be you have to have a reality of some sort. You wouldn't allow me to say there was nothing, absolute metaphysical or philosophical nothing. You won't allow me to say that. That's somehow inconsistent with self. But you would allow me to posit that there could be a reality, one to a customer, one, and with some number of cosmoses attached to it, and that this reality could be completely mindless, And yet that's not what we find. I mean, when I say not just the ultimate reality is mindless, but it could be, it's a possible, metaphysically possible state of affairs that not only the ultimate reality with a capital R, but all the cosmoses that exist could be utterly mindless. All the cosmoses could be utterly mindless. So why isn't that the state of affairs in which we find ourselves?
Because there's some features of the fundamental nature of reality that allow worlds that
No,
do.
but there's another fundamental reality that didn't have those features. Why not? Why wasn't that?
No. There's only one fundamental reality. And it doesn't.
Couldn't there have been a different fundamental reality? Just one of them, not this one, but a different fundamental reality. There has to be a fundamental reality.
Yes.
It doesn't have to be the one we find ourselves in. It could be another, unless you're sort of saying that everything that is necessarily is. Philosophically has to be a priori, not a posteriori, because we know it's true, but a priori had to be exactly this way, no other way. I'm asking you why there couldn't have been an ultimate reality which had it, whatever nature it has, was such that not only was it mindless, but everything it produced was mindless. Why wouldn't that have been a possible state of affairs?
It is a possible.
You wouldn't allow me to say that there could be absolutely nothing because you say that's not possible. Why isn't the mindless state?
It is totally possible to have a mindless universe. It is possible that
not a mindless everything, including the reality and all the universes that it does or could produce.
So it is conceivable that there is a necessary thing, the fundamental nature of reality that created no minds whatsoever. That is possible.
And could not create minds.
Sure. Yes.
Okay. So then why don't we have that?
It's just not its nature. Like, why is God's nature God's nature?
That's the way it is.
Yeah, it's a brute fact.
Okay, good. Well, you see, at least with my fundamental reality, it has a mind, which at least gets it to square one as far as being able to produce minds. Whereas your necessary being isn't really a necessary being. Your necessary being, you're fudging, because your necessary being is reality. You say reality must exist. But then we learn that there are many different possible kinds of ultimate reality. There are ultimate realities that could create universes, or there could be ultimate realities that don't create universes or create mindless ones. Your ultimate reality has contingent properties that are not at all necessary. All you've actually shown, I don't think you've shown it, but you've asserted apodictically that there must be an ultimate reality.
Yes.
You're not allowing me to.
The same thing applies to God.
Me to say there could be no ultimate reality.
The same thing applies to God. So God is all contingent.
Okay.
So it's impossible. It is impossible for any necessary reality, any hypothesis of necessary reality to have necessary properties. That isn't an option. Anything I can assert it's a necessary thing. I can just adopt necessitarianism and say the properties of the quantum particle will necessarily produce exactly this universe and nothing but this universe.
We only have 2 minutes. Go back. Okay. Then so far. Okay, fine. I'd love to come back again, because all of these subjects about the laws, about ultimate reality, and about what else we talk about, multiple universes and mind. One final thing, I was very glad to hear that you're a moral realist, because some of my physics friends are not and some are. What do you mean by that? I just want to make sure that we're not going to talk past each other. By
moral statements have truth value independent of humans, human existence, human minds, any minds.
Independent of what people think about them?
What any mind thinks about it. So yes.
Okay, so there might be certain deeds that are immoral objectively, even if everyone in the world thought they were moral.
Even if every mind thought they were immoral. Yes.
Including all human beings, and maybe all other minds.
Yes.
Thought they were more. They thought they were okay. They would still objectively be immoral.
Yes.
Okay. Now I want to talk about that next time we get together. I want to say, so how do you know that?
Same way we know scientific facts. So I think it's a fact about reality, just like any other fact. So
Can you test it?
Yes, I believe we can.
Okay, so I think you'd agree that pushing an old lady in a wheelchair down a flight of stairs is bad.
Yes.
I think we agree. I agree.
Unless she asked for it.
Let's say she didn't. I think we would both agree that that's a meaningful statement about reality, and it's true. It's not testable. I have a friend, my friend in grad school, a guy from Israel, very smart guy, super smart guy. Anyway, I remember having dinner with him once at a physics conference, and he was asking me how I could make statements, makes assertions that certain things were right or wrong. So because there's no way to test, there's no way to experimentally test whether it's wrong to push the old lady down a flight of stairs. And you can say, well, if everyone acted that, if you could make, well, if everyone did that, or if it's going to cause a woman to suffer, or maybe if everyone did that, it's, if we didn't have certain rules, then society would fall back. Then it just begs the question. It just leads to the question: well, how do you know it's objectively wrong for society to fall apart or for people to suffer? I mean, ultimately, there's no test. I mean, if somebody came along and said, I think Nazism is okay. If somebody said that to you, I think not, so what? Or I think it's fine to torture little animals. If somebody said that, you can't prove. You and I would agree that guy's a schmuck, but there's no way to prove by an experiment.
I think there is.
Can we talk about that next time?
Definitely. I can actually give you like a 1 minute primer to give you something to think about. So I think that,
unless you define it. Now, I think you could define.
Let me tell you my answer, and then you can.
Yeah.
So my answer is that morality is a higher order emergent property like fitness. So it's not the same as fitness. Fitness is an analogy. So fitness is a higher order emergent property that is a description of how organisms and their physical constituents can interact with the environment and its physical constituents. And so that feature is an objective feature of reality. Fitness is a real thing, and we can measure it. I think morality is the exact same kind of thing, a higher order emergent property. But instead of describing a relationship between the physical constituents of an organism and its environment, it's describing the physical interactions of agents in an environment and the capabilities of those agents. And they can. So that's how I think we can actually measure this. So I'm a moral realist, a moral naturalist.
Oh, interesting. This is very interesting. I'd like to talk about that further. By the way, I think you can develop a naturalistic theory of morality.
I agree.
For example, Aristotle did it. But I don't think it's testable. I mean, but in a certain sense, I think you either come down to, if you try to stay completely naturalistic, I think you either come down to simply defining what you mean, making the statement the predicate moral is simply a matter of definition, of sort of arbitrary definition. And then you're not really talking, when you say that this act is moral, you're simply saying it fits the definition, and you're really talking about the application of words. You're not talking about shedding light on reality itself.
Right, I think it's a thing.
I could find a good coffee cup and a bad coffee cup, and I could say I'm going to define good coffee cups as ones that have certain colors, certain shapes, certain patterns on them, and so on. Other ones I'm going to call bad. Then it is objective. It is an objective statement to say this is a good coffee cup given those definitions. It's objective, but it's only telling me about my definitions. It's not actually telling me.
I think morality is a thing in reality, like a law of nature, like gravity. So it's objective in the fact that it exists.
I'd love to see how you pull this rabbit out of the hat.
Definitely. Yeah, I would suggest that you look in the Stanford Encyclopedia of Philosophy has a really great page on moral naturalism, which it gives the premises and explains in detail essentially the primers of my position.
Okay, very good. By the way, as I said, I do believe in naturalistic, but I don't. It's the testability. It's the testability that's the issue.
Yep.
Because you said at one point that you only believe things that are testable.
Well, only things about the world. So I can believe things about my mind that aren't testable. It's fine. So there's a caveat there. Testability is how we differentiate imagination from reality, but you don't need to test imaginary things. You can just grant they're imaginary.
Oh, okay. But anyway, all right. So good. Let's. I guess we went over. I really enjoyed this. I think we've made some headway, because I don't think people can convince each other, but you can lay bare their assumptions and how much they're willing to swallow.
Yeah, I think the conversation is more about the interesting conversation, not about changing minds. It's just about having fun.
I want to plug my organization again, because if you're, I assume a lot of your listeners are scientifically oriented.
Yes.
And so our organization, Society of Catholic Scientists, we have 1,300 members. About 70% of them have PhD or doctorates, not just PhD, in natural science or math. We don't do the social sciences. Natural science, and then there are grad students and some undergrads. And we have conferences. There are videos of our conference talks. There's articles already. There's 12 articles up there. I think people will find interesting. We have bios of Catholic scientists of the past, important Catholic scientists of the past. There's 87 bios of them. There's a bunch of interesting stuff, and there's discussions of questions about science and faith. They're up there. So I think there's a lot of meat people might find interesting. And if any of your listeners are Catholic scientists, they might want to join. It's very cheap, $20 a year.
Cool. Yeah. One thing I would suggest is if you guys can make a way to interact, like a Discord server or a way to like host regular conversations, a YouTube channel, and you have people like yourself come on and chat.
I mean, we've thought of how, having debates and having, we do have talks, and we've had some Zoom talks lately where people, you don't have to be a member to go to the Zoom talk, and you can send in questions. And then there's a moderator who selects the most interesting questions. Otherwise, it would be chaos. But there'll be actually a talk in February about asteroids. It's not anything philosophical, by the director of the Vatican Observatory, who's an astronomer, and he works on asteroids and stuff like that. Anyway, but you can watch that. I'll put up information about that on our website in due course, and it'll tell you how to go to these talks. So we're trying to do more of that, bring in the general public and stuff. We just don't have any people who can moderate discussions. And if you don't have them moderated, as you probably realize, they could quickly degenerate really badly.
Yeah. So send me an email with the link to your website, and I'll post it in the comments.
Thank you.
Awesome. It was great having you on. It was a fun conversation as always.
I like to come back. I want to hear
definitely. All right, I'll check in with you probably like next week or something about rescheduling.
Okay. So. Very good.
Have a nice day.
You too. Bye.